Everybody. I'm Don Kennedy, a proud Tech First member with the company, and I'd like to send a very special welcome to each of you here today for our 14th annual Taste of IT. Sorry about that. I'm having some audio issues. So again, please join me in thanking our sponsors today, Cincinnati State, Cadre. You can check out the additional sponsors on the website. And special thanks to our annual partners, ATC, Fidens, CareSource, Cincinnati Bell, Google Round Tower, University of Dayton, Wright State University, and Uptime. Let's go ahead and let's get started. Our speaker, John Dages, today has over 15 years of technology leadership experience. John brings a unique and essential perspective to enterprise customers for their cloud and advanced analytics journey. John leverages his data, application development, systems integration, and I/O background to offer a complete picture of how companies can apply machine learning to drive competitive advantage and engineer true intellectual property. Excuse me. Join me in welcoming John Dages from Fusion Alliance as he discusses identifying the quick wins in machine learning. John, the floor is yours.
Thank you, Don. Well, good morning, everybody. Again, this is John Dages, and today's topic is going to be the quick wins of machine learning. Quick thank you to Don for moderating today, as well as the other folks that have put on another good conference here under difficult circumstances. This is one of many years I participated in this, and happy to participate again this year, if in a virtual fashion. I do hope all the folks out there are doing safe and healthy, and I'm very happy to see that many folks have come out here to help sharpen the saw, despite the imperfect situation. So hope everybody is safe and healthy. So on the topic today, we've got about 45 minutes. It's my intent to speak for about 42 to 45 minutes on the quick wins of machine learning. I do invite everybody to please chat the questions if you have anything as we go through this presentation, and Don will facilitate those up if we during the actual presentation itself. If you want to wait till the end, we'll spend just a little bit of extra time, at 10:45 here to help address some of those questions. So don't be shy. Let's hear your questions, get your questions answered for you. So the plan for our time today is we're going to do a very quick introduction to machine learning. What is it? Why is it good? We'll talk a little bit about the challenges with today's ML programs. I think for how long ML and AI have been in the hype curve, as well as looking at this conference's agenda, we have probably some degree of familiarity. I think there are a lot of nascent programs that are out there, but we're going to explore a few of the challenges of those programs as they stand today. Then we're going to turn the coin over and look at some of the components of successful ML programs. What are the characteristics and attributes of these good programs? We're actually going to go through some quick wins. What are the universal quick machine learning wins that you can take advantage of if you're starting a new program or looking to expand into other advanced analytics? And then last, we're going to spend a good deal of time talking about composing models or agile machine learning model development, which we're going to cover in detail when we get there. So before we get started, a little bit about me. So again, John Dages. I'm the Solutions Director for Machine Learning at Fusion Alliance. Fusion Alliance full services IT consulting with offices in Indianapolis, Columbus, and Cincinnati. So I think a lot of folks may have heard of us for the basis of this conference. But I've been very fortunate to spearhead a great majority of our machine learning and advanced analytics efforts here at Fusion. That experience really has run the gamut. So everything from financial services and banking, which includes ML engineering such as securities pricing, trade analytics, trade sales, risk and investment management, all the good use or banking use cases that you typically find out there from larger commercial banking providers. Also done quite a bit of work in retail. Columbus, Ohio is where I'm based, and we do have a lot of pretty substantial retail out here, but mostly a focus on dynamic pricing for consumer goods, customer engagement, including retention and cross-sell, and components out there. Also a little bit in pharmaceuticals and hospitality. But it's been a fun journey going through machine learning these past many years, and hopefully I can share some of that experience with you on the quick wins. So let's start at the top. What is machine learning? I think this is a fairly sophisticated crowd, but just anytime I do one of these machine learning presentations, I like to use this quote, which I've stolen from NVIDIA, which is machine learning is at its most basic, the practice of using algorithms to parse data, to learn from that data, and then make a determination or prediction about something out in the world. Now, while that sounds interesting, it really does represent a fundamental shift, of how we deliver, technology services to our frontline staff and to our customers at large. But what is machine learning? Let's compare and contrast, a learning exercise with how we as human beings do it versus a potential machine learning model could in this future state. So how do you and I learn? How do human beings learn? So we learn through experience, right? If we're trying to seek a pattern, we use things that we can touch, things that we read, things that we see, things that we feel, right? The way we go about the world to try and learn new things is through that whole concept of experience. Now, when we talk about systems and programs and applications, that's a little bit different. These machines are a little not as good at, learning new insights, but rather very good at following instructions, following code. And when we look at all the IT systems we built over these many years, we always have a human that's in there, defining the logic, defining the rules, defining the code that these machines can actually go and execute. What machine learning does is turn that equation around. So what we say here is, in lieu of, actually having to program and define, all the rules of a system, of an application, we teach the machine to, in essence, learn from the experience, learn from the data. We talk in terms of machine learning, we say we give the ability of these systems to be able to learn from their past experiences, and past experiences in the form of data. Now, these same machines are able to capture and identify, patterns in this data well beyond the capabilities of any human being, and then most importantly, be able to use those insights and that pattern recognition to make a prediction about something in the future, given new data. So foundationally, when we talk about machine learning, we are saying that, we are teaching a machine that has no rules programmed in to take data, understand what the patterns are, and then given new data, be able to make a prediction about the future. And that's exciting stuff. So ML challenges, it's not easy. And I think a lot of folks that I've talked to, and I've looked at the attendee list, have some nascent experience in ML. But sometimes we observe that some of these machine learning programs, as we just start off adopting advanced analytics, haven't gone the way we necessarily want. So the metric I have is some 87% of modern ML programs never make it to production for one reason or another. And having done this for a number of times and working with a variety of clients, this is what we typically see that are the impediments, to getting these ML models live and actually into the hands where they can actually make an impact. And perhaps number one, and we'll go into detail, but we see, a lot of our clients, a lot of our partners have a tendency to swing for ML use cases that are pretty complex in the cognitive science space, visual analytics, general computer autonomy, vision, text-to-speech, and these complexities have resulted in their inability to be used live. We're going to talk about that in a sec. For another one, we've got teams that have been able to generate pretty advanced machine learning models that are productive and statistically valid, but are difficult to get in production from an operationalization standpoint. So I'm going to talk a little bit about that. And perhaps on the opposite end of the spectrum, we've seen a lot of clients of ours that actually went too narrow, that had great machine learning programs, but ultimately didn't solve the business challenge they were after. So going into a little bit more detail about what that means. So when we talk about complex use cases, it feels that there's generally a gravity towards doing the really exciting and the sexy things for machine learning. Like I kind of mentioned, the cognitive science pieces, the sentiment analysis, the computer vision, all those different components. And they are great and they are valuable, but they are challenging, right? Especially for nascent ML programs, while there probably isn't as much, expertise or depth yet. There is a tendency to swing at these really difficult machine learning components, of which, though, it's sometimes difficult to actually drive, some of those actionable metrics, right? And we start talking about complex use cases, we also start to talk about an adoption of pretty complex tool chains. ML can be expensive. If we're talking in terms, again, of visual analytics and things of that nature that are not, simply data or table-based, it does require a pretty big investment in tool chain, data processing, model training, and things like that. This does require some degree of complex tool chains. And perhaps last is if we start exploring some complex machine learning use cases, it is very challenging to get super smart data science folks that are available to support these complex programs. I did see there's a lot of folks from some of the colleges here, which is fantastic. Data science is a wonderful, wonderful, good field, but there are not enough of you out there. So, finding these folks that are out there can be very expensive for, medium and enterprise size organizations to help, merit your program moving forward. But the other spirit of the thing that we look at as challenges to the ML program is, again, these challenges around operationalization. So if we look, and again, anecdotally here, we look across the spectrum of our customers across a variety of industries. We do see a lot of these nascent programs beginning in the data science space or the technology of the IT space, and that's great. But sometimes we have a problem where even if we have, again, statistically valid and good machine learning models that can make great predictions, we don't see a broader adoption. So there isn't that alignment with some KPI, with some business objective. Frankly, we just, without having that piece, it's sometimes difficult to get these models live and get them working. If there's one single problem with ML programs too to account for here is this concept of finding good data. So again, I'm sure we have all, a lot of, transactional history that resides in our Oracle, our data warehouses, our SQL servers. But, as companies continue to grow and scale, and participate in new lines of business with merger and acquisition activity, sometimes this data goes badly, and there is bad data, which unfortunately, impacts our ability to do good predictions. Of course, we can train on bad data. Our computers can, or our systems and our machine learning models can account for that bad data. But the more good information we have going in, the better predictions we're ultimately going to have out. Biggest challenge of these ML programs. And then the last is some of the machine learning pieces here are a little bit new, and it's not as tried and true as deploying SaaS products in a modern IT portfolio, or not how to build a custom app and deploy it. Some of this data science thing is a little less sophisticated when it comes to actually deploying these data pieces. And because of that lack of sophistication, sometimes these models are harder to deploy than other components. Last thing, and I'm going to move a little bit more quickly. Sometimes, again, we have some narrow use cases that we have to account for versus the complex use cases. And sometimes they just don't drive enough value. So by way of example, again, some experience here in the financial services and banking space, we partnered with a large bank to answer a machine learning question, which was, hey, in my existing banking, my consumer banking portfolio, which ones of my customers are likely to attrite, right? Which customers are likely to leave the bank? So the team did a great job and produced an amazing model, that could accurately predict, surprisingly well, whether a customer is going to leave or stay. So that got presented back, to the CMO of this large bank. And the question is like, well, I'm sure this model is correct, but the people that are likely to leave my bank are the folks that have, low dollar balances or overdrafts or haven't had account activity. And while the model is super good, and in conceptually at least, model attrition or customer attrition is a very valuable use case, it wasn't giving enough to actually, impact, the way they were doing business in a substantial way. Where they really wanted to get to was this idea of not only do I care about if a customer is going to leave, but what if a good customer is going to leave? What if I can predict somebody who's got good valuation with the bank, loss of assets, potentially buy multiple products? How do I know if those folks are going to leave? Which is a broader question than originally asked. We're going to hold on to that thought, because we're actually going to come when we start talking about composable models of how we turn those discrete, smaller use cases into something that can actually empower decision making from a large scale industry. So let's talk about the quick win. That's why we're here. Don, really quickly, any questions that you take a look at, or should we just keep on trucking?
Yep, none yet.
All right, good deal. So let's talk about the quick win. So components of the program before we actually go into specific use cases. Here are some of the attributes and conditions of programs that we find to be largely successful that have really moved the needle for some companies out there. So number one is asking good questions or defining good use cases. We'll talk about that. There's a tendency to go for automation versus custom or bespoke machine learning models. We'll talk about that in detail. And then others are, again, selecting impactful ML components that actually drive changes in behavior, that drive decision making, and then, again, are composable or can make a story out of multiple small pieces. So going into a bit of detail, this is, again, a good fundamental question as you think about kicking off your nascent ML program, which is the concept of good questions and use cases. So going into detail of what this looks like, to give you a quick indication, this is typically how we engage, with machine learning projects. It's very similar to, what's out there today. So number one, if we think about the ML program, we go through this exercise of, capturing and vetting these use cases. What's the most business impact? What's the most realistic? What's not the most complex? Let's find and capture some of these use cases in partnership with the other business units on our group. Once we've captured what that is, and we'll talk about that, but once we capture what that question, that use case is, we go through a process of data capture, which is let's bring in all the different data that may drive predictive value towards that use case. So that could be transactional data, that could be analytical data, that could be third-party public data, it could be data we buy. What information can we bring to put together and use that to drive a high statistically valuable machine learning model? From that, we actually engineer the models. So with all that data, oh, and by the way, that capture part is a substantial part of the project. Actual ML development, or ML model development, actually involves proportionally less on the actual model development than it does, wrangling data from place to place. But that's neither here nor there. So once we have all that data landed, we can actually start to exercise that, and apply our machine learning tool chain to try and develop a model. And then we want to go live. So traditionally, these ML models are serviced through web services, which means if I want to integrate it to my ERP, my CRM, my custom app, my website, I want to be able to expose these insights via web service where I can feed these web services new data, get a prediction out. And then last is support it. So monitor it, continue to improve, the model statistics if that's important, or potentially use other or adopt another use case to continue to iterate. Fundamentally, this is an agile process, or can be an agile process, but these do define kind of the steps. But again, number one question is, again, what is that going to be, right? So finding in the very beginning, what are the use cases that are truly drive an impact, that is definable, is predictable, and can drive out the greater program, right? So this may not be the biggest component as far as time or investment for a larger scale ML initiative, but finding the right ML models to develop is the hardest part. So what's a good question? If that's important, what's a good question? So good questions are those that are specific and actionable. So a question could be, will a specific customer leave in 6 months? A good question is, will this device fail in the next 3 months? A little more nuanced, a little more composed, but again, how likely would a specific customer, how likely will a specific customer buy a product at this price? These are all questions that have an answer. These are all questions that we have predictive and labeled data on, and good candidates towards the overall ML program. So those are good questions. Something we see, and particularly for ML programs that initiate, out of the data science, and the technology groups, is there is a bit of a propensity to want to engineer custom or bespoke machine learning algorithms and models, right? That is to say, we want to do our own statistics, generate our own algorithms, et cetera, right? And the reality is, it is very challenging, for you to beat, some of the automated, machine learning technology that's out there with a custom model. And even with some of these automated technologies, substantially less time to market, substantially less time and investment actually having these data science resources and a variety of things that are out there. If you are starting ML models, there are a variety of automated ML technology and platforms that can do a lot of the heavy lift around machine learning without that huge statistical or data science dependency. Even if you're going in that direction of building a custom algorithm, I would certainly start, explore and determine feasibility and predictability around these models with one of these automated ML products. So if you're wondering where those exist, they're all over the place. And chances are you already have access to at least a few of those guys. Where we've seen a great deal of the innovation is actually from the cloud provider standpoint. So if you and your team and your organization are adopting workloads on AWS, on Google, on Microsoft Azure, all these platforms have amazing, really, really strong, perhaps better than some of the other SaaS products and ML designated products to try and start and perform some of this automated machine learning. Also, if you're a larger enterprise and have investments in Alteryx and SAS and these other big, package data platforms, these tools are getting baked in more and more to enable automated ML. If you want to be more open source, there are platforms that are out there. Again, even the cloud providers and the data platforms are typically adopting, some of these open source accelerators. And again, if you have some SaaS and COTS products, the Salesforce of the world, the SAPs, the Dynamics, chances are that ML is already there for you, and they also have the hooks to try and drive better automated ML adoption just by virtue of using the platform. So automated ML is a much easier way to move forward, especially in the early phases of these ML programs, and chances are you're pretty adjacent, a platform that can perform this kind of activity for us. Again, in the spirit of moving us along a little bit here, there are other factors to consider for the high value ML use case is those that are impactful. So picking use cases that drive good ROI, because that's typically where the attention and budgets, are aligned to. And then I wrote that perhaps a little pejoratively, but how do I put it? So in lieu of, things that may be more technically interesting, where I think I've seen a lot of our, our partners and clients go in that direction of very interesting statistical problems, chances are, the folks that we partner with on the business side are interested in less complex and more direct, kind of KPI driven pieces. So again, when shopping for these, ML use cases, the ones that do move the needle on the business side generally are the most successful. and other ones that are generally better funded. From a good ML use case, it's important to distinguish business intelligence from machine learning. ML is not BI. So ML is very good at, taking data and being able to make a prediction about new data in the future. It's good at making a decision. It's not the world's best for analytics and discovery, right? So if I wanted to be able to look, and understand and explore the data and components of my program and my my company, traditional BI, that's certainly the place for that. When we start thinking about, and we're going to talk a little bit about this, about driving some insights from ML, yes, that does work, but ML is at its best when it can answer, a single question. Is this A or is this B? How much or how many? Generally, the ones that actually are more decision-based are more valuable candidates for ML versus purely exploratory kind of tooling around like the BI tool chain. And the last is, what's interesting is sometimes their ML or anybody else, it's impossible to get, true predictive analytics out of some data. Whether that's bad data or whether it's just something that, confounds predictability based on too many different components. Sometimes these ML programs you start just won't have predictive value. So when thinking in terms of that, sometimes it is better to fail fast, start small and then use multiple ML models versus one monolith and get this data into a platform, an automated ML platform where we can see the lift. We can see that the data set actually warrants predictive behavior and use that to build out my larger ML program. So while you're here, while many of you are here, let's actually talk about some of the quick wins that are out there. I'm actually going to go industry-wide and maybe give some examples across a variety of lines of business inside a larger organization. But you'll see one thing in common, which is a lot of the things that we're suggesting fall in the green of what I've been taking to calling the complexity continuum. Again, I think if you've heard one thing from me, kind of swinging for the fences and complex models is probably not the place you want to be in the very beginning of your program. But there are differences between some of these use cases and programs, and most of the ones, well, all the ones we're going to look at here are certainly in the green. So speaking in terms of complexity, what are straightforward machine learning programs that are relatively easy to answer as compared to some other pieces? So examples are things that are straightforward are things that fall under classification and regression, which to oversimplify is a matter of, again, does this ML, or is the question we're asking, is it true or false? Is this A or B? Is it one of two or three classes? One of these three categories, pick it, right? And we'll see use cases like that. When we think about terms of regression, we think about how much or how many, like how can I predict along a line of what a price is going to be, of what a risk factor is going to be, give me a number, a static number, and then I'll leave that there. And then when we start getting a little more complex, as we start speaking in terms of unsupervised learning, so again, highly valuable and very good, but can become a little more complex. What's nice about some of the classification and regression components is that the data that fills and builds those ML models are called what we say is labeled, which means if I look in my, my history of my data, I know the outcome, of that risk of that customer. Did a customer buy? Did the customer not buy a product? Did the customer leave? Did the customer not leave? We've got all the information that goes back. It's labeled. We know what happened to them. And it's much easier for an ML program to be able to model that behavior given those type constraints. We start talking about unsupervised learning. We have a scenario we don't have labels in the data, that it isn't as straightforward. So think of a problem such as, customer segmentation, right? I want to be able to determine what types of customers run across my enterprise. So that's not going to exist in the data necessarily. There's not going to be an answer, okay, this is a high net worth person from the Midwest. It's going to be a little bit less supervised and a little more challenging to deliver from an ML standpoint. Fully capable of it, but looks a little bit differently. And the last, again, cognitive, we've talked about it, models that simulate human behavior, NLP, sentiment analysis, those are very, very hard and they are hugely valuable. But if you're starting your own center of excellence around machine learning and things like that, probably best to wait on those. And if you're going to go in that direction, probably better to adopt a SaaS product or something that's out there from some of the big technology vendors, because that is a big commitment of investment in dollars. But what actually are some example use cases that we see across all industries and lines of business where we've seen great success in our ML programs is, and let's go through it. So from a marketing standpoint, retargeting or cross-sell, one of the more intuitive ways to be able to market customers that you already have with other products and services. So we know them from A, we want to try and sell them B, who those candidates are, when to solicit those folks, great ML questions and a big part of our portfolio. Personalization, How do I give the customers what I want? Or how do I market, or what modalities and what techniques do I apply to market to my clients? This person might care about, price sensitivity. This person might care about convenience. This person might care more about whatever their personalization factor is. Let's get the right message to the right person at the right time. And then there's others, but that's the marketing piece there. From a sales standpoint, we've done a lot of work with our customers on the sales side, which includes everything from lead scoring. So given a list, and we'll look at an example of this later, but given a list of potential leads, what are the folks on that list that are actually likely, to convert into a new customer, into a new client? Same thing on the generation side of all the data and solicitation, the information I get here. Who are the actual folks that I need to go after? And there's only so many sales cycles, and being able to capture the people that are likely to buy is probably the best way to increase those conversions. From the customer service standpoint, how do I value my customers, right? So if I need to think in terms of, I've got a customer who's unhappy, for one reason or another, do I want to make that customer a bespoke offer? Do I want to lay some margin off the table so that I can keep this as a customer? What kind of decision making happens around that? Is it worth it for me to make this concession, or is this a customer that I want to, maybe not, put as much of an investment in? We also get to questions, again, lifetime customer value that, again, maybe I'm willing to take a little of a haircut here. Maybe I'm willing to offer an incentive that may lose me money in the short term, but can I actually see what this customer is going to be worth to me and my organization over the spectrum of the next 5 or 10 years, and use that to inform a decision of what kind of product or incentive I want to offer? Now, operations may be a little bit more industry specific, but operations is just a wonderful, we see a ton of use cases across the ML things. Not the biggest buyer, which I suppose is a little bit strange, but from operational standpoint, there's a ton of good ML use cases. From the automation of production and other repeatable processes, that lends a little bit more on the RPA side, but the robotics process automation. But can I find those repeated tasks, that your team members are doing on a daily basis, and be able to better inform, prioritize, and route those components from an operational standpoint? Relying on an ML model, allows you to better optimize your operations staff. Worth more than a bullet point, but manage the supply chain and flows. How do I determine, how my partners are going to operate, what my expectations should be based on past performance? And again, predictive maintenance, whatever the assets are. One of the good ML use cases we haven't talked too much is, again, about predicting, when some of these devices will fail, when they need replaced, and again, be able to understand how we can get ahead of it before those problems become expensive. Finance, and I do want to speed up a little bit. From a finance standpoint, how do we do contract management? How do we manage our investments? What are good investments? How do we develop more effective reporting and compliance? How do I actually reach in and find actual predicted outcomes versus just plugging in the formulas, which is somewhat less valuable? And then a risk management standpoint, how do I understand and predict my risk? Whether this is financial services, retail, or anything, we all have a concept of risk management. And again, having that incumbent data, labeled data with our outcomes, we can also see, different techniques to understand where this risk is going to take us and how it needs to be managed. Other obvious use cases, and again, if you learn any of that ML, you've probably heard about credit card fraud detection as one of the most obvious ML use cases, and it super is. But other forms of fraud detection, anti-compliance, if we know what to expect, we can detect, using ML, deviations from the norm and be able to manage that risk in its time and its place. So the last thing I want to bring up, and we've got 15 minutes here, is again this idea of composable models. So for the folks that are in nascent programs, this is probably the part that may be more important, and again where we've seen our most success when generating and developing these ML models. So what is an ML model, or what is a composable model? What we can typically see is sometimes there's a bit of a diminishing return when we continue to invest in one individual model. This is interesting and perhaps out of the scope of this discussion, but long and short, what we'll typically find is that when we go in and put advanced analytics, good ML models across operations, sales, marketing, that everybody loves the model, but the lift is in the first deployment. So if we can predict next best action with 85% accuracy, or if we can predict, dynamic pricing with a deviation of like less than 0.3, if we get those kind of numbers right, is it really that much more impactful to me to get a precision number from 75% to 76%? Probably not. So most of the lift of these programs happen when they first get deployed, and stabilized. And then it probably doesn't make as much sense to continue to dive in the deeper components. But regardless, what is nice about composable models is we can actually start to, again, think about this in an agile way and start to add model to model to model that try and drive an overarching, business goal or KPI, right? So what does that mean? Let's use an example. I'm going to give you an example. So let's go to the sales and marketing piece. And let's say we want to use ML to determine if a customer is going to want to buy a product, right? So ML is good. That's not the topic of this conversation, but ML can tell us some things that are very valuable to me if I'm serving a sales and marketing function, for my company, right? And if I've got and I'm making this up. So say I'm selling a product or a widget, I've got maybe 100 folks that are out there that I potentially want to solicit this product to. Of those lists, if anything like the ones we've seen, chances are 60 of those 100 people are garbage, right? They have nothing to do with your product or service. We'd be wasting any time we have, trying to talk to these folks. Just bad lead generation, bad leads, et cetera, right? So maybe 20 of the folks are applicable, but for one reason or another aren't in the marketplace for the product or service you're trying to offer. Maybe some of those folks actually are, in a good position to hear a marketing or sales message from you and your company, but just isn't the right time in the cycle. Like they just bought a product, maybe they're a little loyal to a competitor. Maybe they would be in some point be ready for a message, but not really yet the time. But if we could focus on, just the folks that, would be in a position where we could influence a decision, we can target and focus our sales and marketing dollars there. So by way of example, let's talk about Bob here. So let's say we want to build a model, to capture what's the likelihood that Bob is somebody that we can market a product or service to. Let's say we have some interaction, we have some history with Bob, we have some information on him that we collected or we bought, we have some information on random Bob, right? So the question becomes, at the first stage of a composable model, should we be targeting and should we be selling to Bob? So ML, like I say, is good at finding patterns in data. So let's take a look at how he's interacted with us, both inside and outside of the relationship with your company. Let's look at some of his demographics, some things we know about Bob. How old is he? Where does he live? Does he live in downtown Cincy? Is he in the suburbs? What's his gender? Again, what can we pattern recognize, using information we know about Bob as well as other people that have bought my product? And then maybe some degree, limited at this point, but maybe some interaction, with some of the email marketing campaigns. When Bob's engaged with us, what has he looked at? What's he interested in? All that kind of stuff. So what ML, and it shouldn't be a surprise, what ML can tell us is that, hey, we think Bob actually has like a 55% chance to buy your product. And that's good, and that's valuable, and that's independently, that independently drives some value to your organization. But perhaps a better idea is, what if we could actually expand that and make this a little bit more sophisticated? So, okay, we think Bob's somebody we want to, provide a sales and marketing message to, but what if we could figure out, not only is Bob willing to buy, but what is he willing to spend? So let's advance this a little bit more. So again, we knew before that, he had some interaction with my brand, but let's see if we can go in and look a little bit more in his product history. Like, what products are he exploring? Is he looking for discounts or sales? If he's looking for products, what is the refresh cadence, on those specific products? Again, let's see if we can find a pattern to see what he's willing to part with from a cash standpoint. And again, maybe we can enrich some existing data we have now with, demographic data, like what's Bob's typical median income by his home address? If this is a convenience shop, or what's the distance to, potential, retail outlet or an office, distance where your organization can deliver that service. And then potentially some questions around interaction. So we talked before, hey, he was on the website, he clicked on the sales campaign, but this could be, again, framing this up, what his interest is and what he's willing to pay. Where did he click on the website, right? Did he, make this was he making a buying decision while he was at work? Was he making a decision for a personal standpoint, which both have different buying behaviors? And what time of day did he engage with our brand? Whatever it is, whatever data points we have on Bob. But again, now we can ask a more advanced question. So how much is Bob willing to pay? Okay, now we know he's likely to buy, and this is the maximum we think he'd be willing to pay, to buy our product. This is a use case we see everywhere on the dynamic pricing thing, especially for non-consumer good services. But the question is, when we offer a price that's more generalized and more universal, in every scenario, we're leaving some degree of money on the table. If we can get really smart about what Bob wants and what he's willing to pay for that service, we can actually deliver him a targeted, dynamic price message. We see a ton of that kind of work. And last, again, thinking about taking these small models and serving an overall goal. And to be quick, how valuable is Bob really to me? So maybe we think now in terms of valuation. So if we're thinking about, okay, we know he's going to buy, we know how much he's going to pay. What do I want to do? Like, how do I track Bob in the short term if I've got good valuation across Bob across a 5-10 year horizon? So again, I know things, this isn't Bob related, but I understand different things for my organization, which is, what is my acquisition spend? What is my sales spend? What is the cost of goods? What are all the different components that make up the service I'm trying to offer? Maybe I have a deeper understanding of exactly how much I make, from each one of these discrete products or services I offer, including, what's the expended revenue, if there's risk factors for non-performance. And then again, how do I take those dollars here and what else can I put Bob into, right? So maybe he's buying widget A, maybe he wants widget B. If we get him in with, service A, maybe he'd be more open to, a different, revenue opportunity from a different service B, et cetera. So with that in mind, we can take, we now assume that, based on Bob's profile, before we even have a deeper relationship, this is the guy that we really want to go after, right? So this is a guy that's going to buy all the products and services from my company, or this is a one-off guy. And if this is a one-off guy, maybe I'm not as willing to make a sales concession, early in this relationship cycle. But if this is somebody, if we hook them with this, they're going to be with us forever, they're going to be a great partner of ours, then maybe I'm willing to be a little more generous around my incentives for some of these products, given that consideration. So thinking about in terms of composable models, this is what I mean. So it never stops at one. It's never, is a customer going to buy a product? It's never dynamic pricing. When we see super advanced machine learning initiatives and machine learning programs, it's that we take all these small models and the aggregate of all those different models represents more than the sum of the parts of the model. So also when we go this direction, we do get some agile delivery. I brought up a little bit earlier in this talk that, being able to work on little discrete line level questions and use cases does empower that to be developed, I don't want to say in isolation, but independently without the huge long-term expense of extremely complex models. We can be more agile. We can produce more models and get to the result much more quickly. We can talk in terms of mitigating bad investments. Again, I mentioned that not all models are predictive. Not all data is predictive. And if we need to make a different direction or make a different choice here, we can know that early before we sink so much time and investment in there. And the last is when we think about composable models, we're ultimately driving towards Drake or towards making a decision. The models that we've seen, we think in terms of bringing these together to a total goal are almost always related to some kind of KPI or business objective. And this composable model is the way to get it there. So I've got 5 minutes left. Is longer than I wanted. I apologize, but I do want to do a quick summary and I want to start entertaining the questions. So summarize, when we think about machine learning, if you're starting your own ML program or if you're thinking about other opportunities inside your organization, is that from a summary standpoint, the ML models that are most successful for you are those that are high value, that operate in real time, and those that drive predictive decision making, right? Exploratory analytics is not the big use case for ML, but if I can put something that will actually impact, behavior of some of your frontline staff or people that work in your organization or engage with your customer. If you can have an ML piece that actually drives decision making and drives, actual change in behavior, those are hugely, hugely productive. Also consider the quick wins. I brought this up multiple times. Don't swing for the fences on your first guy. Some of these non-sexy, kind of ML use cases we talked to as part of this presentation, they may not be super interesting from a technology, a data science, or a development standpoint, but they're often hugely valuable and they're hugely underserved, even for large organizations, has been my experience. And if you're going to go this direction, I do encourage you to consider things in terms of composable and agile models versus building the one and total universal monoliths. So I can't wait to hear your questions. I'm going to turn it back to Don to help send some of those my way. But again, I want to say thank you very much for a little time to talk this morning. If you want my contact information, there it is. And with that, I think I'd like to move on to the questions. Don, you want to take it away?
Absolutely. Got a couple different questions. So let's start with a little bit more on just word soup. So I think in the marketplace you hear machine learning, automation, RPA, intent, a lot of confusion. Maybe provide some insight into what words belong in what buckets, because there are some very real differences between automation, machine learning, and all the rest of it.
That's an enormously complex question, Don.
We got 5 minutes.
No, it's a great question. One of the hardest things, and obviously whoever shared this question with you, Don, has probably had the same experience I have, which is not only are there a million terms for the same thing, but people use them differently. So let me help do the segmentation of kind of what this is speaking about while still offering up, other capabilities and terms that are out there, right? So machine learning, which is the level we're at here, is part of an overall umbrella that includes artificial intelligence, right? So artificial intelligence is anything that makes you think, that would make a system or a product think and act and reason like a human being. And that's the whole that's everything. So that's everything from self-driving cars to autonomous surgery to whatever your recommendation engine is on your Facebook for what shows up in your feed, right? So at the broad level, AI is any of those things that help, systems think and reason like a human being. We're talking in terms of this, in the spirit of the word soup, of machine learning. So machine learning is focused just on that process of using machine learning modeling or algorithms to parse through existing data and then be able to make a prediction about something in the future. So I mentioned a lot of examples for AI, but when we think of, exploring data, understanding that data, making a prediction, when I think of the examples there, that's less, self-driving cars, although it is, and more in terms of, again, recommendation engines. So you go to Amazon, you buy a product, you put it in your shopping cart, you get 4 or 5 recommendations. That's a machine learning engine. When you go to Netflix and you click on a movie and it suggests some other opportunities for you, that's machine learning, right? So there's also another component of machine learning, which is probably the hippest when it comes to this, which is this concept of deep learning, which again is non-directed machine learning. So think neural networks and components like that, where semi-autonomously these models can go out and infer and direct their own predictive analytics around a given data set, without that providing some degree of that intent or concept, and use that to drive predictive value. So when I think in terms of machine learning, I think I'm talking about that middle tier. It does involve different techniques and approaches to machine learning, including deep learning and neural networks, but also more traditional statistics. ML is sexy. It is a big part of the word soup that's out there today. Machine learning also includes things that chances are you learned in your 6th grade, statistics classes. Like, what is a logistic regression, right? What is an SVM? What are these other traditional statistical techniques that have been made easier to use and consume by virtue of some of the advancements in ML technology? Some of these, they're not all neural networks. Sometimes they're just traditional statistical models, and sometimes they're even more productive than the complex, expensive, and difficult to train deep learning networks that are out there. So hopefully whoever asked that question, that's an amazingly good question. Hopefully I gave you a somewhat nuanced answer. But that's at least how we term it. As far as the industries that's out there, those are the terms that we use for the folks that are, quote unquote, in the business here. Don, do we want to entertain one more question?
Yeah, let's take another, actually 2 short questions. You talked a little bit about funding. Maybe speak to generally, I think most people underestimate the funding needed for even small projects, but maybe give some insight to where to start thinking about funding, and then who within the organization you found to be better advocates for machine learning.
Got it. It's a fantastic question. A really good question. So again, this is kind of the business of what we are into, is again trying to solicit and find, folks that are willing to make that investment to try and realize some kind of business outcome, right? What I also brought up before is, sometimes a lot of the original requests as we start to develop relationships in this space, are maybe more on the technology side, the data science side. So what techniques, what approaches do we take when we talk in terms of funding? So not only is that question good, we've formalized that process internally here because it is so fundamental to making these programs successful. So what does that formalization look like? So we exercise something that's called, it's called the ML workshop. And what we'll do is this. So we will invite business parties from a couple known and high value lines of business to send representatives and talk about what machine learning is, why it's valuable, and help narrow down on potentially what some of these use cases are. So before I go into that, how we got here is, we're invited in, let's talk about machine learning. It's top of the hype curve. Everyone wants to talk about it. How do we convert that into something that could be potentially funded or used? So we bring the folks in. Again, if we bring in the MOs of the world, the senior directors of, sales and marketing, if we bring in folks from operations, from finance, from HR, which we didn't talk about, we can bring these principals in. They're going to want to talk about it because it is exciting. It is kind of a sexy topic. So we bring those folks in and then we kind of walk them through the workshop. So a lot of this we talked about today. So we walk these business principles. What are the conditions of a good ML program? What potentially could it add value for you? And then we ask these teams to contribute. So given these scenarios, given these constraints, how do we think, how do we think we could impact, what you're trying to accomplish over there? And then it's open season. So we'll collect and, as part of this formalization to, collect ideas that are out there. And some ideas are good and some ideas aren't very good. which is fine. But we go back up there and we actually go through a process of, in essence, vetting. And I assume your questions in terms of nascent ML programs, like how do I get my first big quick win?
Yeah,
But we'll what's that?
I said yes. Getting started, I think, was the heart of that question.
Yeah, so getting started, picking that use case is just a wonderful good idea. But we'll take that list of that input from other, principals from across different business lines, decide ones that conform, to some of the constraints we talked about in this conversation. What's an easy win that's not complex, that the data is retrievable, I have in the data store, I don't spend a bunch of money, right? And then demonstrate and show what that can kind of look like. What a successful program for a sales and marketing for an operations team could look like. Align that to what they've said, make it their idea, which is part of our techniques there, and say, hey, this is a question that machine learning can answer, right? And when you get there and you can say things like, hey, you're soliciting 100 people and you should only be targeting 2, we can give you the 2, then that conversation gets a little bit easier. So to summarize that whole thing, it's a hugely important thing for nascent programs. To be able to try to bring people together, to get their feedback, to directly align, with whatever the principal or the funder is trying to accomplish, and then bring those thoughts together to work towards execution. And I think when we get that alignment, they understand the value, I think the funding falls out of that pretty readily. Do we have time for one more, Don, or are we done?
No, I think we're at the hour. So I want to thank you again, John. Great topic, great presentation. Special thanks to CommSpark, our feature sponsor for this session. If you would remember to complete the survey for each session by going back to this session, scrolling all the way to the bottom, you'll see a feedback survey. By participating in that survey, you're making your voice heard and are really helping shape the future technology first events. Thank you for taking the time in advance for filling out that survey. We've now got a 15-minute break, so grab some snacks, visit the exhibitors in the event platform. There are game codes you can earn by exploring the app. Go to the event game tab to learn more. The game code for attending this session is machine, and we'll see you guys at the top of the next hour. Thanks, and have a great day, John.
Thanks, Don, and thanks, everyone. Have a great afternoon. Great morning.